Hello, my name is Alp. I'm studying electrical and electronics engineering at Bilkent University. In this video, I will present my Physics 102 lab project, which is about measuring the capacitance in parallel plates. The aim of the experiment is to investigate how the capacitance changes when the plate size, the distance between the plates, and the material between them are varied. Um, the whole experiment was based on the capacitance formula, and also the theoretical values were calculated using it. The required equipment for this experiment is a multimeter, five different size aluminum plates, a glass plate, paper sheets, and a foam board. In part A, I first placed two aluminum plates with the same area parallel to each other. Then, using the multimeter, I measured the capacitance value. I repeated the same process for each different aluminum plate. As you can see, I recorded the values in table 1. The capacitance value increases as the plate area increases, which is consistent with our formula. I also plotted the graph using these values. The graph clearly demonstrates that the relation between capacitance and the plate area is a linear. After that, I analyzed how capacitance changes when the gap between the plates increase. Since the error percentage is lowest in the 20 centimeter plates, I used them for the rest of the experiment. I attached the plates and then increased the separation between them. Again, I measured the capacitance values and recorded them in table 3. The observed capacitance decreases as the distance between the plates increases. In plot 2, I drew the graph for various plate separations. The plot shows that the capacitance value is inversely proportional to the plate gap. For part B, I investigated how different dielectric materials affect the capacitance. I placed the aluminum plates and using different dielectric materials, I measured the capacitance value. I first set the distance to 1 centimeter and placed the foam board between the plates. The foam board fully covers the whole gap. However, for the glass and paper sheets, they only cover half of the gap. Therefore, the capacitance behaves as two different capacitors are connected in series. In table 5, the observed capacitance values can be seen and the relative permittivity is highest in glass. By the way, relative permittivity is higher when the material is a better insulator. For each stage of the experiment, there were errors that occurred while measuring the capacitance. For each measurement, I also calculated the expected capacitance value using determined values and the formula. In general, the main sources of errors were the misalignment of the parallel plates, surface irregularities on the aluminum foil, and imperfections in the experiment setups, and also the measurement errors. In part B, the errors become larger when the dielectric material did not fully fill the gap. Since the dielectric could not be placed perfectly flat between the plates, it increased the measurement error. Despite these errors, the whole experiment was successful. In conclusion, this experiment clearly demonstrated how capacitance changes with plate area, plate separation, and dielectric materials. The results from all stages of the experiment followed the expected theoretical trends. Even though there were some experimental errors, the overall behavior of the system matched the theoretical predictions very well. And thank you for watching.